All right, we are going to look at another thing around tangents. Okay, what I'm going to do is zoom in and just come over here. What is the definition of a tangent? What is it? A tangent? Okay, a straight line that touches the circle, it's not going to go into it. So I'm going to put a dot anywhere on the outside, okay? I am going to draw two tangent lines from this to the circle. Okay, there's a tangent line. Let's draw another tangent line from the same point to the other side of the circle. Okay, what this now means is that these two lines, up until they touch the circle, are equal. Okay, so from any point, it doesn't matter. Let's do a different one. I'm going to draw one over here. Actually, let's draw something completely different. I'm going to draw one here and prove the exact same thing. All right, let's make this purple this time. All right, so if I go there and then again on this side, that means that these two are equal, right? So any point, it doesn't matter. I'm actually going to undo that just because it's making it more complicated and messy. All right, let's go back to this color. All right, if I now draw two lines like this, Timothy, what did you say before about these lines?
They're really cool.
What did you say about them? What's it called? What's the name of the line? Yeah, it's a radius, right? It's not a trick question. These are both radii, which means they're equal, right? Anywhere from the point to the outside of any point are all going to be equal. So that means these two lines are equal and these two lines are equal. And the special rule that you very, very seriously need to know that they will not tell you most of the time. They are going to assume you know this. They're going to draw these pictures and ask you to assume this knowledge. Anytime a tangent line touches the circle and meets at the radius, so a tangent line meeting a radius, it's always a right angle. This is a very common thing that they're going to assume that you know. Same on the other side. These are, oh, geez, I hate that. So a tangent line that touches a radius is always a right angle. Okay, any tangent line that touches a radius forms a right angle. I'm going to have to try and redraw this. There we go. No, it's like the radius is going to same point on the outside, right? Now, if I drew, so also, and actually, if I drew a line right up the center of this, what have I made? Yeah, I have made two equal right-angled triangles. This is really helpful for working stuff out. If I've got a kite, which is what that is, that can be confusing. But if I make it into two right-angled triangles, it's easier for me to work out unknown things. These two angles are going to be equal, aren't they? And these two angles are also going to be equal. So I now have two perfectly congruent, remember that word congruent means all the sides and angles are equal? These are congruent triangles, and they're right angle triangles, which is even better. This rule is going to be really, really important. They're going to use it a lot.
So that those two sides are equal.
Which two sides? This one and this one? Yes. That one and that one are equal, and these ones and these ones are equal. Okay, well, these are both radii, right?
So even if I move it like this, it's still.
Yeah, so if you think about what I did before, so let's try a different color and I'll prove my point. If I do a dot, let's say my dot is now, I don't know, here, right? If I do the exact same thing to, oops, if I do that line and I do that line, why is it not, why does it, there we go. Okay, so if I do this, and then I draw from here into the center and from here into the center. See how these two are equal? They're all four of them are equal. These two are equal. And I can split this down here. These are both right angles. These angles are the same. These angles are the same. So it doesn't matter where the dot is. This is always a true rule because it's all proportional. Because you have to get to the center of the circle and you're only allowed to touch the outside, you're limited by the dimensions of the circle. So this always works, okay? It doesn't matter where the dot is, how far away it is.
Are we building a skyscraper or something?
Well, sometimes they make questions like this and it's about space. There's like a satellite out in space and this is the Earth and how far away is the satellite? Like sometimes they put questions like that. Okay. All right. Let's just draw one more circle.
And the
All right.
2025 year comes to an
I hope 2025 isn't coming to an end right now. Okay. All right. So if this, what is this line called? Not Pokemon. What is this line called? Okay.
Let's go get you.
Jeez. All right. So if this, that's not a chord, this is diameter. It goes through. No, it's not. Boo. We know it's not the same thing.
Go catch our claws today, man.
All right. So I know some information about this now. So this, I know that this is a diameter, but aren't all three of these equal in length?
Yes.
Because they're all coming from the center. They are all radii. So if I made some extra lines here, if I joined C and B and I joined C and A,
Square.
what do I know about C and B and C and A?
They're all.
They're equal. Well, if they're so if this is a radius, oh, because sorry, I should have said these are right angles first, shouldn't I? So if I said what's the definition of C? Actually, let's call this O. Why am I calling it O? Because it's the center. What does O stand for? Not center. Origin. Good. O stands for the origin. What did you say? All right. So let's have a look at this. What is the name of CD to AB? CO, sorry.
CD.
CO to AB. What is the name I gave that line before? Yeah?
Yeah.
You're not being, okay, it's a perpendicular bisector. It's both of those. Perpendicular bisector. All right. So it's really important if they tell you that CO is a perpendicular bisector to AB, then you can mark in your right angles, which is going to give you information about what's equal. And you can use Pythagoras on something like this, which is nice. If you're being asked to find unknown angles, which you might be asked to do, what are you now going to use?
The other one.
Pythagoras is for lengths. SOHCAHTOA, right? For right angle triangles. Well, this is the difficult thing, right?
This is recording, right?
Yes, it is. Okay. I'm also going to remind you of stuff we already know. Okay, let's zoom out a bit. Let's zoom out a bit. Oh, that's okay. I'm going to save this. I'm just saving it. Okay, so I'm going to remind you of some things we already know when it comes to angles. I'll put this back up in a second, okay? All right. I've saved it. I'll put it back up. If I give you this and I tell you that this is 110 degrees, what else do you know? This is 110. Anything else?
Yeah.
Why is this 70? It's a straight line. Okay, they might give you things like this in circles.
It looks like a Brazilian flag. No, the Jamaica one. Oh, yeah.
Oh my goodness, why does it do that?
You know how
Now they're doing.
Okay, let's say that the question gives you something that looks like this. What do you know about anything to do with this shape? Do you know anything? What do you think? This one? Okay, I'm going to say you're making an assumption based on the way I drew it.
That's a 9.
This one? Okay, it might be true because it looks like that's how I've drawn it, but I wouldn't make that assumption. What else do you know about this?
It's a triangle.
Hang on.
Point where the perpendicular bisector is E. The angles there are 90 degrees.
Here? Okay, you're making an assumption there. That might be true, but I have not given you enough information. What do you think? I have not said it's an isosceles triangle. You just made that assumption. I didn't say that either. It might look like that, but I actually don't think that these two angles look equal. But either way, even if this was a perpendicular bisector, I didn't tell you that, so don't make that assumption. Is there anything you can assume from this picture?
There's a right angle triangle.
There's a right angle triangle. Is there anything I have not labeled that I could label?
The line.
What do you mean by that? You're right. Oh, okay. You mean let us know. Are there anything about the lines that I know?
They're straight.
Straight. What about the diameter? It's not two diameters. Oh, there are two diameters. Okay, so this length is equal to this length, right? Because they're both diameters. Don't we also know that these two are equal?
No.
Well, it goes through the origin, right? So this must be split in half, which means these two are equal. Should I have drawn it like that?
No.
Why not? That's right. They're all radii, so all four of these are equal. I'm also going to say that this angle is equal to that angle, right? That's what we just talked about. And this angle is equal to that angle. So annoying. I don't know. I don't have enough information to work out anything, but at least at this stage, you should be able to say that's equal to that. This is equal to that. Those two angles are the same. And then when they give you some numbers, then you can start working them out. Okay. So even if you're told that this is X degrees, you can say that this is also X degrees. Well, how would I talk about this angle here if I didn't have another letter? Right. Isn't this 180 minus X? Because these two have to equal 180. So try and think about, what do I know? Even if you label bits of things, if you can't do the whole question, it might help you.